When dealing with a static transfer switch, or STS, rated for 50 amps continuous with 260 amps input fuses and slots for 3 output fuses up to 30 amps, it is crucial to understand how to determine the maximum permissible overcurrent protection for both the input and output circuits. Let's begin with the input overcurrent protection. The static transfer switch has 260 amps input fuses. The combined overcurrent protection offered by these fuses would seemingly be 120 amps because 2 times 60 equals 120. However, the continuous rating of the static transfer switch plays a vital role in determining the maximum allowable overcurrent. In this case, the switch is rated for 50 amps continuous. This means that the switch is designed to safely handle a continuous current of 50 amps without overheating or sustaining damage. Therefore, the maximum input overcurrent that the switch can safely handle is limited by its continuous rating, which is 50 amps. Even though the fuses provide 120 amps of overcurrent protection cumulatively, exceeding the 50 amps continuous rating of the switch can lead to potential hazards and equipment failure. It is essential to ensure that the overcurrent protection does not exceed the equipment's rating to maintain safety and reliability. Now let's consider the maximum output fuses. The static transfer switch has slots for 3 output fuses, and each fuse can have a maximum rating of 30 amps. If all 3 slots were filled with 30 amps fuses, the total overcurrent protection for the outputs would be the sum of the individual fuse ratings, which in this case is 3 times 30 amps. That is 90 amps. However, similar to the input overcurrent protection, the continuous rating of the switch must be taken into account. The switch is rated for 50 amps continuous, which means the total overcurrent protection for the output should not exceed this value. Even though the fuse slots can accommodate up to 90 amps of overcurrent protection in total, exceeding the 50 amps continuous rating can result in the same problems as before: potential hazards and equipment failure. To ensure that the total overcurrent protection for the outputs does not exceed 50 amps, you can use 1 or more fuses with a rating less than 30 amps. For example, you could use 2 20 amps fuses and 1 10 amps fuse, which would provide a total of 50 amps of overcurrent protection. Another option would be to use a single 50 amps fuse, if the design of the switch allows for it. The key is to ensure that the sum of the fuse ratings does not exceed the continuous rating of the static transfer switch. Let's delve deeper into the practical implications of these considerations. Firstly, the selection of appropriate fuses for a static transfer switch is not merely a matter of matching the fuse rating to the wire size or the load requirements. It also requires a careful evaluation of the equipment's continuous rating and its ability to handle overcurrent conditions. Secondly, the continuous rating of the static transfer switch is often determined by the internal components and the thermal management capabilities of the switch. The components, such as the switching elements, conductors, and connectors, are designed to operate within specific temperature limits. Exceeding these limits can lead to premature failure and potentially hazardous situations. Thirdly, the overcurrent protection devices, such as fuses or circuit breakers, are designed to protect the equipment and the connected circuits from excessive current flow. These devices are intended to interrupt the current flow in the event of a fault or overload, preventing damage to the equipment and reducing the risk of fire or electrical shock. Fourthly, it is important to note that the overcurrent protection devices must be properly sized and selected to coordinate with the other protective devices in the system. Coordination ensures that the protective devices operate in a coordinated manner, minimizing the extent of the outage and preventing unnecessary tripping of upstream devices. Fifthly, in addition to the continuous rating and the overcurrent protection requirements, there are other factors to consider when selecting fuses for a static transfer switch. These factors include the interrupting rating of the fuse, the voltage rating, the ambient temperature, and the specific application requirements. Sixthly, the interrupting rating of the fuse is the maximum fault current that the fuse can safely interrupt without failing. The voltage rating of the fuse must be equal to or greater than the voltage of the circuit in which it is installed. Seventhly, the ambient temperature can affect the performance of the fuse. Fuses are typically rated for operation at a specific ambient temperature, and their current carrying capacity may be reduced at higher temperatures. Eighthly, The specific application requirements may also dictate the type of fuse that is used. For example, some applications may require the use of fast-acting fuses to protect sensitive electronic equipment. Ninthly, when selecting fuses for a static transfer switch, it is always best to consult with a qualified electrical engineer or a licensed electrician. These professionals can help you to determine the appropriate fuse size and type for your specific application, ensuring that the equipment is properly protected and that the electrical system is safe and reliable. Tenthly, regularly inspect the static transfer switch and its associated overcurrent protection devices to ensure that they are in good working order. Check for signs of damage, overheating, or corrosion. Replace any damaged or worn components immediately. To reiterate the key points, when selecting fuses for a static transfer switch, remember to firstly consider the continuous rating of the switch. Secondly, ensure that the total overcurrent protection does not exceed the continuous rating. Thirdly, select fuses that are properly sized and coordinated with other protective devices. Fourthly, consult with a qualified electrical professional for guidance. Fifthly, regularly inspect and maintain the equipment to ensure its continued safe operation. In summary, understanding the continuous rating and overcurrent protection requirements of a static transfer switch is essential for ensuring the safety and reliability of the electrical system. By carefully selecting and installing the appropriate fuses, you can protect the equipment from damage, reduce the risk of electrical hazards, and maintain the integrity of the power distribution system. Remember that the 260 amps input fuses provide a total of 120 amps overcurrent protection. However, the continuous rating of the switch is only 50 amps. Therefore, the maximum input overcurrent that the switch can handle is 50 amps. The switch has slots for 3 output fuses, each with a maximum rating of 30 amps. Therefore, the maximum total overcurrent protection for the outputs is 3 times 30 amps, which is 90 amps. However, the continuous rating of the switch is only 50 amps. Therefore, the total overcurrent protection for the output should not exceed 50 amps. This can be achieved by using one or more fuses with a rating less than 30 amps. It is also important to consider the National Electrical Code, or NEC, requirements for overcurrent protection. NEC Article 240 provides general requirements for overcurrent protection, including the selection and installation of fuses and circuit breakers. NEC Article 700 provides specific requirements for emergency systems, including the use of static transfer switches. These articles provide guidance on the proper selection and installation of overcurrent protection devices to ensure the safety and reliability of electrical systems. For example, NEC Table 310.15b16 provides ampacity ratings for various conductor sizes and insulation types. This table can be used to determine the appropriate conductor size for a given load current. It is important to select conductors that are adequately sized to carry the load current without overheating. Overheating conductors can lead to insulation damage, reduced equipment life, and potentially hazardous situations. In addition to the NEC requirements, there may be local codes and regulations that also apply to the installation of static transfer switches and their associated overcurrent protection devices. It is important to consult with local authorities to ensure compliance with all applicable codes and regulations. Moreover, the installation of a static transfer switch should be performed by a qualified electrical professional who is familiar with the equipment and the applicable codes and regulations. Improper installation can lead to equipment damage, electrical hazards, and potential liability. So, the topic covered has been about how to properly protect the static transfer switch using overcurrent protection, and this is the way it is done, taking into account the continuous rating of the static transfer switch, and understanding all the codes, regulations, and safety considerations. Also, remember to consult with local authorities to ensure compliance with all applicable codes and regulations. Furthermore, ensure a qualified electrical professional performs the installation.